2, 1 second. Start.
Hi everybody, my name's Duncan and I'll be your host this week for AzureDiY Season 2, Episode 4. So for those of you who are new here, we run Azure-related content every week where we bring in experts to present on different Azure topics. And this week, I'm very excited to have Ahmed, who will be talking to us about using true PaaS for containers and deploy on app services. We run these every week, and so if you haven't caught the previous ones, they are available on LinkedIn. Especially last week's one was pretty awesome as well, talking about geo-redundancy, which is well worth checking out on our LinkedIn community, which you can see from this link here. So everything that we have here, you'll be able to see after this. So a couple of housekeeping rules on what we're talking about here. This session will be recorded and will be put on both this LinkedIn page and also on YouTube afterwards. And as we go along, we really encourage you to ask questions with the Q&A forum. So while you're here, you can just click on the Q&A button and then ask your questions as you go, and we'll do our best to answer them as Ahmed is presenting, but also at the end, we'll stop and answer those questions as well. Now, for the most exciting part to me of the day, we're going to do a little Q&A before we hand it over to Ahmed around the topic. So first question, so you can just hit your Q&A button in Teams and leave your answer to this. So be ready now, just answer this question. So what is a container? Of course, a container in computing, not container in your kitchen. Is it A, a service that hosts code to a website, a custom library for another application, a unit of software that packages up code, but not its dependencies, or a unit of software that packages up code and all of its dependencies? So I'll just give you a minute, hit that Q&A button and jump in and answer this there. So I'm just going to make this a little bit easier and limit down the questions.
Still waiting on the answers to come through.
Thanks, Shree.
Yep,
and
we
then,
have got option 4. One answer is option 4.
Well, that's good. And that is the answer. A unit of software that packages up code and all of its dependencies. Okay, so let's move on to the second question. A little bit trickier this time. Docker, the most popular containerization platform, when was it founded and what language was it written in? Was it 2013 with Python, 2010 with Go, 2013 with Go, or 2010 with Python? So I'll give everyone a minute just to enter their answers again into the Q&A section. I'm sure there's a few people going, how come they didn't do it in C#? Or maybe Shree thinking, why didn't we do it in Xamarin?
Exactly. Yeah, absolutely. We should have written in Xamarin, yeah. Xamarin is the place to go, you know?
Okay, so I'll limit these down a little bit further.
We have got some answers. 2 answers, 2010 Python, 2010 Go.
Oh, then we limit out some of those. It's now down to one of these two. You have to be a bit of a container buff to...
2013 Go, we have got another answer.
Awesome, and that is the actual result. So 2013 written in Go. So that's 7 years old now. So that's been not cutting edge, is it? So it's well and away in its journey. Okay. And another question, what is the name of the Azure service used to host web applications? Is it Azure Apps, Azure Websites, Azure Web Service, or Azure App Service? I've got a feeling we're going to get a few more people who know this one in the chat. any answers in there yet?
No, no answers yet. Let's app service. We have got the first answer is app service. App service, app service. Oh my God, everyone knows it.
Yeah, I thought everyone would know that one.
Yes.
Yeah, I don't remember the date.
But you didn't know that. Come on.
No,
Hey,
I wasn't so sure. I had to go through the PowerPoint. No, I'm just kidding. Okay,
Yeah.
so I think everybody is quite familiar. And if you're not, you should check out Azure App Service, and we'll have Ahmed talking a little bit more about some of these tools today, which is one of our core offerings, which is pretty awesome. So with no more wait, I'm going to hand you over to Ahmed to take the screen, and he is going to present to us today. So thank you, Ahmed.
Thank you very much, Duncan. Can you see my screen? Just to make sure.
Yes.
Excellent. Cool.
Yep.
Hey,
You're
everyone. Yeah. Hey, everyone. Thank you very much for joining us today. Just a very quick intro about myself. My name is Ahmed Elsayed. I work for Insight Group as a principal consultant in the apps and infra team. I've been in the industry for almost 15 years now with a background in app development, in web, mobile, SharePoint, BI solutions, universal apps, and almost everything Microsoft thought of. Before switching my focus for the last 5 years towards Azure, infrastructure, DevOps, Kubernetes, and Terraform. I've been consulting for the last almost 5 years now with Insight and other big consultancies. And mainly what I do now is help organizations migrate and optimize their infrastructure in the cloud. Also, I'm specialized in app modernization and helping teams to transform and utilize the cloud, and of course, mainly Azure. And below here is my LinkedIn and Twitter handle. You can contact me anytime if you have any questions or thoughts. So I work for Insight, as I mentioned. It's a Fortune 500 company based in 19 countries so far, with a workforce of over 11,000 people globally. We have a very broad areas of expertise globally, as you can see. I'm part of the cloud and data center transformation piece, but there are lots of other people, as you can imagine, doing other different things, covering the end-to-end capabilities. We're mainly specialized in app modernization, DevOps, cloud transformation, data solutions, custom solutions, and many other things. So yeah, enough about Insight. And now let's focus on the Prezzo. So my aim today is I want to show you how easy it is to deploy an application, a fresh application into Azure using Azure App Service. And of course, as the name implies, we're going to focus pretty much on containers. The session will be a good long demo, but I'll go very quickly on the slides before going to the demo to talk about our building components and the concepts before we start the demo to get everyone on board. Yeah, so our app today is a React.js app with a .NET Core backend. I'm going to create it using the .NET template. So I'm not going to create the app. I'm not going to go and create the files from scratch. I'm going to use .NET template to create a demo app. And then next, we're going to containerise that app into a Docker image and use GitHub Actions to put that to push that image into ACR and deploy it into Azure App Service. So the whole thing, we're going to do it together from scratch all the way into running in an app service. Don't freak out if you didn't hear about any of these words before. We'll cover everything in the demo and in the coming slides. So this slide is just a visualization of what I just mentioned. So to help you understand what you're going to create. So as I always like to start, I'll start from fresh, as I said. And then we create a project, push that project into GitHub, and then use GitHub Actions to create a Docker image, push that Docker image into an ACR, and then deploy that image into an app service. So in terms of infrastructure, what I'll be doing today is I'll be creating the infrastructure through the portal itself. So I'm going to create the ACR and the app service. I'm not going to do it through ARM or ARM templates or Terraform, just for the sake of the demo and not adding too much complexities. So yeah, but don't try this at work. Infrastructure as clicks, it's not recommended at all. So the first thing is Docker container. It's a very modern and consistent way of bundling your application along with your configuration and dependencies. And this falls back to the first question that Duncan showed before the preso. So yeah, so this way you can deploy your application anywhere and on any machine without having to worry about prerequisites or configurations or blaming someone's machine if things didn't work. It's a very portable way of deploying your apps and makes the life of devs and DevOps and infrastructure guys way easier. So basically, like instead of the old days where you have to deploy your apps as files, so a bunch of files, and then you go to the web config and change stuff and all that stuff. This is totally different. So all you have to do is just a Docker image that has got all your application, all your configurations, everything in just one file. I'm going to show you how we can create that and push it into ACR. The next bit is the ACR, which is Azure Container Registry. Think of it as like a bank of Docker images. So when you create a Docker image, you need somewhere where you can host those images in. So previously people would use, or not previously, like still people use it. People still use like Docker Registry, which is fine. But there is a native way in Azure, which is Azure Container Registry, which provides you like full integration with role-based access control and Azure Active Directory for permissions and stuff. And the really cool bit about ACR is the integration with the Azure Security Center, which gives you the option to scan your images in the ACR and make sure that you don't have any security threat in your images, which is a really good feature for enterprises. Azure App Service. So we spoke about the Docker image, we spoke about the ACR. So Docker image, we're going to host in ACR, and then we're going to deploy it into Azure App Service. So Azure App Service, it's the similar to what you used to do with IIS or hosting a web server in a Linux machine. It's the native way of hosting an app. So this app can be some files like a normal web app in .NET Core or any other language, or can be a Docker container, which is what we're going to see today. Azure App Service provides you like really cool features like scaling up, scaling out in case you have high loads in your app, and you can set this to happen automatically. That's the last slide, talking about the building components, and my favorite bit that we're going to touch upon in the coming demo is the new Microsoft baby, as I like to call GitHub and GitHub Actions. So GitHub Actions is the native built-in CI/CD tool in GitHub, and not only it does CI and CD, but can do lots of other automated stuff that you can simply trigger on events that happen on GitHub. So for example, if you have a pull request raised against the master branch, you can you can automatically trigger the GitHub workflow to run. A commit happened on a specific branch, a code review is requested, etc. One good thing about GitHub Actions, and as you know, it's the #1 community Git repo tool. You can imagine then the community mass and the workflows that people are sharing, and the power that you get out of that. I strongly recommend you check it out and give it a go if you did not try it before. And trust me, like you're gonna love it. I found the transition from Azure DevOps into GitHub Actions really easy and makes a lot of sense. So before the demo, just again to remind you what we want to achieve to get everyone fresh. So again, we're going to create a new project and then push that project into Git, push the source code into Git, And then using GitHub Actions, we're going to create the Docker image and then host in ACR and deploy it to app service. So now to the demo. So I'll start with creating the GitHub repo. So this is my GitHub. I'm going to go and create a new repo.
Can you please zoom it a bit, please?
Zoom it, okay. That's good.
Awesome.
Yes, that's good. Yeah.
Cool. So I'm gonna create my repo. So I'm gonna call it AzureDiY app service. Okay, and I'm gonna make it public so that everyone can refer to it later on if you need to. And then just add a .git ignore. And I'm gonna say it's a Visual Studio to give me all the git ignore stuff that I need for the .NET Core, and maybe a README file, and then create the repo. So this gives me the repo. It's an empty repo, as you see. So I'm gonna clone the repo. Locally in my folder, I have a fresh folder, nothing in there. It's the AzureDiY folder. I'm gonna bring up my terminal, and as you can see, there's nothing in here. So I'll start by cloning my repo, my fresh repo. And now you can see that there is the folder coming from the GitHub. So what I want to do, step one, is I want to create my .NET app, right? So I'm going to use the .NET new React. So .NET new React, it's calling the .NET like a NuGet template. It's out of the box. So if you try to use CLI, it's going to work. So you have to do .NET new React and then -o, which is the output. You just give it a name, and that name is going to be like the website name or a project name. So I'm going to give it a name as AzureDiY and then enter. And as you can see, it's getting the template, the SP core with React.js template, and it's going to create my project. Cool. So next, I'm going to build. Let me go first inside. Yeah, I need to go inside the folder, AzureDiY, and then I'm going to build my project. And the build is going to restore the packages and get all the npm, run all the npm restores and stuff that it needs to run the application. Should take a couple of seconds. For some reason, since the last patch update from the .NET CLI, there is some issue with the .NET build. So it gives you an error the first time, but if you run it the next time, the second time, it's going to work fine. So I'm going to .NET run the application, and just to show you the application running locally. So it says you can get it here. HTTP localhost 5000. I'm gonna go here and that link, and you can see the application is working. That's working locally without a Docker file, without any containers. So next step is, I'm gonna stop that. Next step is let's containerize the application. Let's Dockerize it. So just for the sake of simplicity, I'm gonna open Visual Studio Code. Is that good enough? Yeah. So so this is my folder in Visual Studio Code, and this is my project folder, right? What I need to do now is create a Docker file and tell it how to build my Docker file, right? My Docker image. So I'm going to create a new file and call it Docker file. And you have to stick to this name, Docker file. You can't call it anything else. Otherwise, you need to explicitly tell it how to run. So we'll just go with this Docker file. And then I'm going to paste the Docker file commands here. For the sake of time, we can just write this in the demo. But I'm going to explain how it runs. So the Docker file is, how to create a Docker image. So any Docker file starts all with a base image, right? So in order to run this application, which is a .NET Core application, I need to grab the Microsoft .NET Core SDK so that I can build the application and then get the artifacts and make it available in that container, right? So the first line here says, grab the Microsoft base image, which is a .NET Core SDK 3.1 as build, and then just install Node.js to help me run the project and build the project, and then run .NET Restore. That's the project file that we have in here. So this is the project file. So it just says .NET Restore, the same way you run it in your CLI, and then .NET Publish, and release everything in app publish. And then the next step is just copy everything from app publish and put it in the container and expose port 80. And my entry point is the AzureDiY DLL, which is going to be my artifact. So I'll save that Docker file, and then I'll jump into the CLI again, and then just want to make sure I'm in the right folder. Yes, there's the Docker file. So I'm going to go Docker build, and then give it a tag, okay, which is AzureDiY. I can call it anything, AzureDiY 123 or whatever. It's just my own preference. So it's just the name of that image, and a dot, which means the whole folder. So I want to build the whole folder. And what's happening here is it's going to go through the steps from first step all the way to the end, and build my Docker image and host it locally in my Docker, my local Docker. For the sake of time, I'll just give it some time to finish, and then I'm going to jump into the Azure portal and create the resources together. So as you can see, it's an empty resource, totally empty subscription, and an empty resource group. So I'm going to create a new resource group and create my two components, which is the ACR.
Sorry, Ahmed, I'm going to bother you a little bit. If you can zoom in.
Oh yeah, sorry. Yeah.
Sorry.
Yeah, it's fine. Thank you for telling me and stopping me. Yeah, so we're going to create the resource group, and we're going to create the two resources that we need in Azure, which are the ACR and the app service. So let's first start with the resource group and call it RG AzureDiY, and I'll just stick with the defaults and create. So resource group is fine. I'm going to go here and then click add, and I'm going to create my container registry. So I can call it Azure ACR AzureDiY, for example. It's going to check if there's no ACR available anywhere with the same name, and this is fine. And then I'll just go with the defaults. Validating and create. Too simple and too easy. So while it's creating, I'm gonna jump into the resource group again and then create my web app or the Azure App Service. So I'm gonna call it, for example, web Azure DIY. Yeah, that's good. And you can see here that we have two modes. We have a Docker container and code. And of course, we're gonna push a container. So I'm gonna pick that one. And the reason there are two options because there are some configuration changes, some configurations you have to add in your app service if you're going to use a Docker container. So Azure is going to do that for you if you pick Docker container. You don't have to worry about doing stuff yourself. So I'm gonna stick with the defaults, but I'm just wanna change the size because it's not a production workload. I don't wanna go with the premium. So I'll go with the cheapest dev plan. The next, I'm gonna go, it just says, you'll have the quick start container to be deployed with an Nginx. I'm gonna go with the defaults and just go create. Cool. Again, while it's creating, let's jump back to the CLI and see what's happening. So the Docker build has been completed successfully, no problems. So let's go and see Docker image ls, which is list for me the images that I have. And you can see there is the AzureDiY and the tag is latest. Now I want to run the Docker image locally before pushing that to app service, just as a way to test that it's working. So I'm gonna go Docker run, and then port forwarding from 80 to 80, and then just use AzureDiY latest, and that's the name of the image. And now it says, okay, it's listening on localhost port 80. So if we go here and then go localhost port 80. Here's my container running with my demo app. Cool. So this verifies that it works. Now it's time to push all the code that I have into GitHub. So I'm going to jump back to Visual Studio Code, and I like to use the extension here, the Git extension. Since this is already connected to my GitHub repo, I can just go here and write my message. So create my demo app, and then click here. This is a local commit, and then click here for a sync with the GitHub repo. So if you go here and then go here, refresh. As you can see, it's empty, but it's still pushing. Yeah, it's done. So, oops. We go back here. Another refresh. You find the folder here with all the files and the Docker file. Cool. So we have the Docker file now. We have the code in GitHub. Now it's time to use GitHub Actions to push that Docker file into the ACR that we just created in Azure, and then deploy that to the app service. Just let's go to Azure and make sure that our resources are created. So this is my resource group. You can see here there is an app service, there's an app service plan, and there is a container registry. So app service plan is basically the virtual machine that is running the app service. But it's something that you don't control, like the virtual machine you don't control as much as if you're using a real virtual machine, because it's a managed service. Cool. So back again to code. Now it's time to create my GitHub action. So in order to create a GitHub action, all you have to do is, GitHub workflow. All you have to do is create a folder and call it .github, and it should be in the root of the of your folder. So .github, and then I'm going to create another folder and call it workflows. That way, GitHub would recognize anything inside GitHub/workflows as a GitHub workflow, and it's going to treat it differently from any other file, and it's going to read it as a workflow and respond to triggers and respond to events. So I'm going to create a workflow inside the workflows folder and just call it my workflow, for example, and it's a YAML file. Again, for the sake of time, I'm going to paste the workflow. I'm going to explain how it works. And again, it's going to be available for everyone in the GitHub repo that I created, and it's going to be available in the useful resources in those slides that I'm going to share after the preso. Cool. So this is the workflow. At first, you can see, oh, wow, that's a lot of code. That's a lot of lines of code. I'm not good in writing this, but hey, it's not the way as you think. It's much easier. You can just read it and you'd understand how it works. And also, these jobs and these steps, I did not write myself. I got them from the marketplace. And I'm going to show you how to get stuff from the marketplace. Cool. So the first item here is the name of the workflow. Just a name. You can call it AzureDiY. You can call it Ahmed. You can call it whatever. So I just call it push Docker image to ACR, and on, which is the triggers, the events that's going to listen to. So for example, here it's going to listen to any push to the master branch. So if there's any push to the master branch, it's just going to fire. And I can also control what's the path that I'm listening to. So anything under the folder source, it will fire. But anything not under this folder, it's not going to fire. So I have that control. Again, there is another event listener here on pull requests. So if there's any pull request against the master branch, it's going to fire, etc. The next bit is the environment, and the environment, they are just variables. So instead of hard coding keys inside your steps, you just create some variables here, like key value. You have a key and you have a value, and just in your steps, you can reference the keys, and it's going to substitute that in runtime. So my variables here are just the container registry that I'm going to use to host my image and use it to pull the image from. And the image name, in case I have more than one image in the ACR, I need to specify the image name. And then the web app name, which is the name of the app service that I'm going to deploy the ACR, the image into. And you can see here we've got jobs, and this is so the workflow has got some jobs, and the jobs are just a group of steps. So the first job is building my image and pushing it into the ACR. The second job is deploying that into an app service. And obviously, every job has got a couple of steps to accomplish that job. So for example, the first job is build, and there are some steps to do this job, the build job. So you can see, first thing is checkout, pull all the files from GitHub, and then second thing is authenticate against the ACR. So I need to have a username and password, and then connect to the ACR using the credentials that I have, and then just push the container into that ACR. Once this is done, the next bit kicks in, which is deploying the web app. And again, first thing is check out the files. Second step is authenticating against Azure. So GitHub, when it runs and it needs to deploy stuff into Azure App Service, it needs to have some kind of credentials as a trust to be able to change stuff in App Service, right? So I'm going to use Azure credentials in that. I'm going to show you how to get the Azure credentials very shortly. And then the last bit is setting up the ACR, the web app, to connect to the ACR and grab the image and deploy it. Cool. So you'll find a lot of placeholders in the code as env.something and secrets.something. So env.something is an environment variable here. So environment.container registry, which is this one. But secrets.something is it's basically a secret. So something like the ACR username and password, I cannot save that and store that in plain text in a YAML file, right? Anyone with access to this YAML file or access to my GitHub repo would see clearly my text, my clear text, my username and password in clear text, and this is insecure. So there's another way I can pass on these variables, but through secrets, not through environment variables. So let's work in this together. Let's fill in the environment variables and the secrets and get to know where to get these stuff from. So first of all, the container registry. This is the registry URL. So if we go into the portal and go to the container registry, you'll find the server URL here. So I'm going to copy this and go back here and paste. Next is the image name. I won't worry too much about the image name because it's the same name that's going to that workflow is going to use to create the image and read the image. So it doesn't matter because it's going, creation and reading of the image is in the same place using the same variable. So I won't worry too much about it. So I just leave it as is, AzureDiY image. That's fine. The last thing here is in the environment variables is the Azure Web App name, which is the name of the app service. So again, I'll go to the resource group and then go to the app service. I'll copy this and paste it here. Cool. Now, the next bit, which is the secrets. So I need an ACR username, I need an ACR password, and I need the whole Azure credentials, like how to connect to Azure. So let's start with ACR username and password. So in order to connect to the ACR, I need to go to the container registry and go to the access keys and just enable the admin user. So enabling the admin user is going to show you, give you the option to connect to the ACR using a username and password. And that's exactly what I want. So I'm gonna copy this, but where should I put that? I need to go to my project, the repo. That's my repo, yep, settings, secrets, and create the secrets here. So I'm gonna create the ACR username and save it here and add secret. So that way, this secret is stored in GitHub. I cannot see it. I cannot view it. The only way I can use it is read it through the code, like secrets.acr username, update it. So if I just forgot it, I can just update it or remove it. But I cannot read it once it's saved and it's just hidden. I need to add another secret for the password. So this one. And again, go back here, grab this password, paste it here, and add the secret. Cool. The very last thing we need to do is the Azure credentials. So I need a service account to connect to Azure. And a service account is kind of like a username and password to authenticate myself against Azure. It's done differently in Azure. So it's called SPN account, and it's done through the Azure Active Directory. But there is a command, there is a CLI command that we're going to run now to show you how to create that. So if you run this command, so AZ, which is Azure, AD, Active Directory, SP, service principal, and then create for role-based access control, give it a name. So I'm gonna change that name and just say final DIY, for example, and then give it a role, so contributor, and then the scope. So this is the subscription / my subscription ID. And if you can see, this subscription ID needs to be the same subscription ID as the subscription that you're using. So how can I get that? Just go to the subscriptions, and you can find the subscription ID against the subscription that you're using, which is 478F. This one, and enter. So running this command, it's creating a service principal for me in Active Directory with the right role against the right scope. And then it's responded with some JSON. So you can see here, this JSON has got some client ID, client secret, blah, 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 blah. I'm gonna delete this account after the demo because this account is going to give you like full control on the contributor control on the subscription. So you can create stuff and you can delete stuff and can do whatever you want. So So I'm going to copy this and then go to the secrets, new secret, call it Azure credentials, and just paste the JSON as is. Do not change anything in the JSON and add the secret. Cool. That's pretty much it. And what we need to do is we need to push that file, the YAML file, into Azure. So again, I'm going to use this extension, GitHub workflow, and push. Cool. Now, if we go back to the code, you should see the folder .github and workflows, and you can see my workflow in here. And the cool thing here is you can click on edit, and GitHub would recognize this as a workflow, and to give you the option, if you want to add more actions, you can search the marketplace and just click and add some actions here. Cool. So let's go to the actions tab, and then you find this action that we created. That's the name that we gave it earlier. So we can just run the workflow manually. But of course, it's going to listen for any pushes to the master branch or pull requests, as it's mentioned in the YAML file. Yeah. So that's the action running. So as we mentioned, it has got two jobs, the build and the deploy. So this is the build. It's running all the steps in here. You can see what's happening. So you can expand and you can see what's happening in details. So you can see it has checked out the files, got everything from the folder, and then container registry login. So it has used the username and password that we created for from the ACR access, and then pushing the container to the ACR. While this is happening, let's go to our ACR and see this is happening. It's my container registry, yep. And then repositories. Nothing in here. Crashing. Still working. So basically, it's doing the same thing that happened on my local machine. So step 1, 2, 3, 4. It's going through all the steps in the Docker file and executing them one by one. Step 8, pulling, 9, exposing, copying artifacts, and it's done. Should be done. Yeah, it's pushing. Cool. So should refresh, and here is my image. The AzureDiY image is here. So the job has been completed. So you can see there's a tick next to build, and since that's the case, then deploy web app is going to kick in, and deploy web app is going to pull that image from the ACR and deploy it into the app service.
Hey, I'll just stop you for a second. There is a question on the previous screen. What is Ubuntu build inside the like the YAML file?
What is what? Sorry.
What is Ubuntu build inside the YAML file?
Oh yeah.
So you just.
Yeah. Okay. So that's the YAML file. There is runs on Ubuntu. So obviously this action, this workflow needs a build agent to run on, right? So there is a virtual machine somewhere that you do not own. You hire it from GitHub, right? And this job is going to run on that virtual machine. So obviously, GitHub has got many machines. It's got Windows machine, Linux machines, Mac machines, etc. So what I'm doing here is I'm going to say I want an Ubuntu machine. I can change that and say I want a Windows machine or I want a Mac machine. It depends on what I want to run here. So if I'm running something related to like a Mac code or something like a .NET 4, .NET Framework 4, then I need a Windows machine. I need to specify this in the runs on. Ubuntu is like the simplest and the most quickest, so that's why most people would go with the Ubuntu if they do not have any restrictions on the machine that they want. Obviously, this is going to run the same across Ubuntu or Windows, but just for the sake of simplicity and a quick demo, we just go with Ubuntu. Cool. So deploy web app has been completed. So now we can just go to the resource group, and that's my app service. And I have that button called Browse. And that's my website. It's a black background because I have this extension. So yeah, that's the app. That's the app in the app service, deployed nicely and working fine. And yeah, that's how easy basically it is to deploy an app to app service. So back to our presentation. Cool. So app services also comes with really nice features like scaling, warm-ups, health checks, etc. So I'll start with scaling, like a little bit about scaling. Obviously, like you need your infrastructure to be smart enough to expand whenever necessary and shrink when the load decreases to save you from paying extra bucks that you don't need. So app services can do that for you using the auto scale feature that you can define. So for example, you can say, if my CPU exceeds 70%, add one instance. If it goes below 20%, just remove one instance. And that way, you're just paying for what you're using. You don't pay too much or you pay too little. So yeah, that's a really cool feature. And also, you can be proactive with scaling. So if you don't really want to wait for the CPU to reach 70% in order to react, you can say, okay, how about in my high trade, if I have a kind of high trade or high load that I'm expecting from, let's say, 9 a.m. to 12 a.m., set my scaling to 20 instances, for example. And after that, scale down to 1 instance or 2 instances. This is possible using the scaling feature in app service. Warm-ups is also a great feature, since you can tell Azure how to warm up your application. So the idea behind warm-ups is, when you run a web application for the first time, it takes a little bit of time for the first request to get sorted and to finalize the request, because under the hood the application is starting up and warming up. So you don't want a frustrated customer, like the first unlucky customer that hits your website. You don't want that. So you can tell Azure how to warm up your application and how to make it ready for the first request. So it doesn't matter if it's the first request or the last request. It's fine. They're all gonna be the same experience. And the last thing is the health checks. So health checks, sometimes things go wrong in your application because of you, or because of your code, or because of your configuration, or because of Azure itself, which is very unlikely, but things go wrong. And I've seen a lot of customers with memory leaks in their code and some problems in the code. And unfortunately, Azure would not be able to tell if your application is having a memory leak and it should stop or not, because it's an issue with your code. It's not an issue with the Azure resource. So This way, using the health check, you can tell Azure how to tell whether your application is dead or not. You can just build like an API or build a page that Azure would ping and make sure that it's up and running. And if it's not running, then it's going to force a restart or do whatever. So I'm sure many of you have heard the buzzword Kubernetes a lot, but maybe some of you may not and may not know what it does. So AKS is actually the native open source Kubernetes, but hosted as a managed service in Azure. I'm not going into details about Kubernetes, but I'm gonna just explain the differences between AKS and app services, because they pretty much do the same thing in terms of running containers. So AKS, it's used to host your microservices containers, but giving you the absolute control on everything. So it's considered sometimes like considered as IaaS, not PaaS. So you have the control on networks, containers, security, disks, certificates, pretty much everything. So yeah, it's a beast when it comes to managing a bunch of containers and easily scaling them. And it does a really great job when things go wrong by fixing itself and auto-healing the services. However, it requires a bit of knowledge and a bit of hard work, and you need to educate yourself on how to do lots of things in Kubernetes. As I said, it's open source, and the platform won't help you much in this out of the box. But that's the same with every platform. I'm not talking about AKS only. I'm talking about Kubernetes in every platform. Yeah, so it needs a lot of education. And the ultimate question that everyone comes across, both AKS and app service, probably ask. That's a question I got a lot from our customers. When should I use app service? When should I use AKS? They're very similar, but when I should use this or that. So I kind of added some points here to just to tell you briefly what's the right direction for you. So app service is true PaaS. It's truly a managed service, much simpler to set up, as you can see. Like, we did the whole thing in less than 20 minutes. Much simpler, easier diagnosis and troubleshooting, and dedicated SLA. And what I mean by dedicated SLA is when Microsoft says your SLA in app service is 99.99, for example. That means if you deploy a web app in your app service, you're going to have this SLA, right? However, even if the SLA of the Kubernetes is very high, but you're controlling the whole thing, Microsoft is not going to guarantee that your configurations in the AKS is going to give you 99.99 availability for your website. So it all falls back to you and the way you configure your Kubernetes, the rules, the networks, and everything that you configure in Kubernetes. So app service also is good if you don't want to manage any VMs, you don't want to manage anything, just worry about the code and don't want to manage anything. But of course, this comes with a cost. Like, it's much more expensive than having an AKS cluster. AKS is more of if you have a lot of microservices, it's more cost efficient, as well as it's easier to manage one AKS rather than managing 100 microservices in app services. So yeah. Don't get me wrong, I'm not against AKS. I'm a big fan of AKS, but I'm just trying to explain when would you use app services and when would you use AKS. So just very briefly, we're going to talk about some solution designs and architecture designs in Azure. So we talked about app service. But of course, your app cannot exist by itself in Azure. So you need some kind of database. You need some kind of file store. You want to save some pictures or some kind of stuff. So you need some other resources. So this is a very, very basic solution design that you can just try by yourself in Azure. So for example, you have a website hosted in app service with a name www.abt.com. And of course, Azure DNS is the one controlling that. So it's going to point your www.abc.com into your app service URL, and Azure Active Directory probably to authenticate users and make sure that the request is authenticated. And then request comes from the internet straight into your app service with a storage blob, which is the storage account you save files in there, and some database here. That's a very basic solution design. A more complex solution design, which is the high availability architecture. As you can see, it's almost the same in terms of if you're looking at one block here, but we've got geo-replication and we've got 2 regions here. And the reason is we want to do some kind of replication in case a region has any issues or has any problems. There is a way that I can divert a call into another region. And of course, these regions need to be paired regions. And paired regions are regions that exist in the same geographical location. So for example, Australia East and Australia Southeast, like Sydney and Melbourne. And the reason is why we need to stick to paired regions, because sometimes, if things go wrong and there is an outage in one of the regions, Microsoft would put that in mind and would make sure that one of the regions would get priority. And if there is an update or patching that needs to be required, Microsoft again will put that in mind and would not do that both regions at the same time, but would do them sequentially. So again, to the design, same thing. There's an internet www.abc.com coming from the DNS, and then it would be pushed into an Azure front door. And what Azure front door does is it's kind of a traffic manager, load balancer, WAF, web application firewall, and it sits in front of your web application. And the Azure front door is the one responsible of diverting the call either to this app service or to that app service, depending on the health of the app service. For example, if this is down, then it would go here. If this is down, this would go there, or the geographical location, etc. Like Azure front door is really, really good in doing this. So again, I really recommend trying out Azure front door with your app service. And yeah, the same thing here. You've got the database, you've got cache, Redis cache for your caching, and geo-replication setup between your databases. Was that it? These are the useful resources. I'm going to share this presentation with Microsoft after the session. This first item here, the GitHub repo, is the GitHub repo that we built today. It has got all the actions, the Docker file that you can reuse, and you're free to copy paste or do whatever. That's fine. Please scan the QR code here to give us some feedback, and for the Azure DIY events in general, to enhance things. And really, we value your feedback very much and would appreciate it. So I'll keep it up here and start getting questions.
That was awesome, Ahmed. I love watching. I love the demo. I love seeing different uses of app servers, especially around containers. It's not something everybody always knows possible. So that was really awesome. And I love your little joke about infrastructure as clicks. I'm going to steal that. And we have a couple of questions. Let me I'll just steal the screen and put our question slide up. So 2 seconds here.
Sure.
So hopefully everyone can see the screen changing into question time. So there's been a couple of good questions in the background. So I'm going to start off with, let me just bring up the questions here for me. So the first question that I have, we've answered a couple as we went with in there, but the first one was from FY. How about using Azure Key Vault instead of GitHub Secrets? Can you just chat to that for a bit?
Yeah, of course you can do that. So as I mentioned, like GitHub Actions, there are a lot of GitHub Actions in the marketplace. So yes, you can do that. You can connect to the Key Vault and grab some secrets from the Key Vault and use that. so GitHub workflow, since Microsoft acquired GitHub, there have been a lot of support in terms of Azure. So before Microsoft acquiring GitHub, it was very hard for you to do anything related to Azure. You need to run a lot of CLI scripts yourself. But after Microsoft acquired GitHub, there's been a lot of new GitHub actions every single day in the marketplace. So yeah, you can definitely do that. Yeah.
And I think there was a similar one here. What is the different / comparison storing secrets on container registry or storing on Key Vault for React.js apps?
Container registry. So that secret that was in the container registry is the secret to connect to the container registry. So I cannot get that key from anywhere else other than the container registry. Pretty much, it's not a secret. A random secret that I need to connect to a database or something. It's just to connect to the ACR.
Okay, cool. And there's another great question that's come in here that I really like. Bishoy asks, so what's the difference now between creating a container to push a web app code to web app service and just pushing directly the code to GitHub to the web app? So I guess they're saying, correct me if you read this differently, or jump in, Bishoy, if I've read this differently. Normally you could just push your code. You could just say, here's my .NET app, and bypass the container. What's the pros and cons there?
So so you're saying, like, what's the difference between using a Docker container versus pushing just the files, the application files, right?
To the app service, yep. Mm-hmm.
Yeah, okay. Yeah, that's a good question. So of course you have both options. You can do this, you can do that. But the good thing about the app service using containers is once you have a container file, it's pretty much consistent. So you can test it locally. You can use app service for that. You can use any other service. That's one thing. The other thing is you bundle all your dependencies and all the configurations into your container, and it's going to be the same consistent experience that you have locally and in app service. So pretty much, if you use code files in app service, you have to do a lot of prerequisites, a lot of configurations, a lot of dependencies, and you don't get that same consistent experience. Yeah, so I really recommend using containers.
Mm-hmm. Okay, excellent. And there's another one here from Michael. Slot swaps can typically be quite slow in Azure, brackets, minutes. Is there an improvement when using containers?
So when doing deployment, he's talking about deploying slots, right?
I think so. Yeah, jump in, Michael, if we've read this wrong.
Yeah, so deployment slots, yes, it might take a little bit of time, but because Microsoft does a warm-up, like under the hood, Azure does a warm-up to the new slot before it goes live. So for example, you have a staging slot and a production slot, okay? And you want to swap them. So what happens is Azure tries to warm up the new slot and makes it ready to start getting requests and serve requests straight away. So under the hood, it just gives it some time to warm up and do everything it needs to be live, like 100% live, and start responding. But in terms of the experience with containers, it's pretty much the same.
Cool. All right, I got another doozy here from Bishoy. How does the health check work? And I think it's related to the second part of his question. So how does this health check work? How can I set up private web app, not accessible through the internet? What do you suggest to use for troubleshooting?
Yeah, good question. So I'll start one by one. So sorry, what was the first one? The
first one was how does the health check work?
Yeah, so the health check works. How does the health check work? So maybe can I steal the screen again?
Yeah, go for it. We've got about, we've probably got about 10 minutes left, so we've got time for more questions. This is great. Thanks, Ahmed.
Yeah, good. Cool. So this is my app service, and I want to go. I'll check.
1 second, the screen is still not shared, Ahmed.
Is it?
Yep.
What about now?
Still Duncan's content. Sorry.
I've just stopped sharing, so I'm not sure.
Okay, I'll stop and then try again.
No luck.
So it's presenting.
Duncan has done something, so yeah.
Yeah,
I must have
I've
broken the internet again.
Possibly.
Anyway, if you go to app service and then on the left hand side, just go down and you'll find health check. And when you enable the health check, it's going to give you an option to give it a pass. So for example, if you have an API that's called /health check, so you build that API, build that action, and you pretty much just put /health check in the path. And what's going to happen is Azure is going to ping that path every, I think, couple of minutes, and it will look for the status that is coming back. So anything other than 200 to 299 is considered as a failure. And what happens is if it's a failure and it's a couple of failures, not just one failure, then it's going to bring that down, that instance down, remove it from the load balancer, and then force it to restart.
So then I think that the next bit moving on from that will be, how do I set up a private web app not accessible through the internet?
Yeah, so
yeah,
that's a good question as well. So there's a new feature called private endpoint. So a private endpoint is a way to connect your web app into a virtual network. So let's say you've got a virtual network, and I want to connect to this web apps. I want to restrict the web app to be only accessible through this virtual network. So a private endpoint is something that sits in that virtual network, okay? And that private network points to the web app, and anyone wants to connect to the web app should speak to the private endpoint. And the private endpoint would get a private IP address from the virtual network. Is that clear?
Yeah, that makes sense to me. It's a very big topic, Bishoy. You're probably already aware of it if you're asking the question, but that's a great little synopsis there from Ahmed, that you basically can give it an IP address that's locked down into your virtual network and not a public IP address using private endpoints.
Yeah, there's a documentation. There is a document from Microsoft. It's just Google using private endpoints for Azure Web App. You'll find the documentation from Microsoft with an architecture diagram showing how you can do that.
And then we got another question here from Nitin. Does Microsoft have any plans to decommission, reduce capacity of Azure DevOps and move everything across to GitHub?
No.
Yeah, I'll take that up. So yeah, so from Microsoft's side, what we're doing is like we are actually heavily investing into GitHub. Both the teams, Azure DevOps and GitHub, has been moved into one single unit, which is owned by Nat Friedman. So if you're talking about, if you're actually creating a new project and doing something new around the DevOps side, we always recommend going with GitHub. If you're already using Azure DevOps and very comfortable in there, you can stay there, and later on we will have a migration path towards GitHub, saying that there is no written nothing that says like it's going to get deprecated, but our investment is more, like 90% of the investment is more towards GitHub.
Thanks, Sri. And there's also, if you go onto our LinkedIn for AzureDiY, we have a session with Anthony Borton on there where he actually goes through from the GitHub Azure DevOps team, and he talks a little bit to this as well. So that's a good session that we did very recently. You can check out.
Yeah, I think it was episode 1, so it was season 2, episode 1.
Awesome. So I think that's coming to the end of our questions here. And I think we have a few more minutes left if anyone wants to jump in and ask any more questions. Otherwise, we'll wrap up here. And
can you please, Duncan, bring up the feedback slide, just to make sure that everyone has got it?
That's a very good point. Let me do that now. Actually, do I have the feedback slide in my deck? Yes, bring that up now. Thank you. So we would love your feedback. We're super excited about these sessions, and they're growing in popularity. So
sorry guys, we are having some Teams issue today, and somehow it's just not changing. It's the whole presentation slide. So I'll send you guys, everyone on the call, I'll send you guys the link to the feedback, so such that you guys can reply with your amazing feedback, and please let us know how you feel about the whole season, so that we can make it much better. Now it finally changed. Yes, you've got it. Yep.
I think it's working on my side. It's just Ahmed's sharing capabilities is for some reason not working.
I'll blame you.
But luckily it was just in time you've done your presentation. So.
Yeah, exactly.
Yeah. Okay, cool. So now, okay, I don't need to send the feedback link, but now you guys can scan the QR code and send your feedback.
Awesome.
Cool.
So I think we're right on time here. We'll leave this up for a second. But thank you, Ahmed. That was awesome. I love watching you present and pulling through so many different things. So that was excellent. And we'll have this up on LinkedIn in the next couple of days or so. So don't forget to go over there and check it out if you want to watch it again, which someone's already asked, or you want to watch any of our other episodes, and join us again next week. So thank you very much.
Thank you.
Thanks. Bye.